So I'm testing different video platforms. This one's a Google one, and I'm see how this goes. See about the quality of the video. I'm already thinking that it's going to continue to readjust the focus, so I'm probably not going to like it, but we're going to try it anyway. Cosine of 2 theta is the cosine squared of theta minus the sine squared of theta. Now, if you were to solve for sine squared of theta, then you would get a formula for the sine squared of theta involving the cosine of 2 theta. So basically it's 1/2 times 1 minus the cosine of 2 theta, and then the cosine squared of theta doing the same thing, it's 1/2 times 1 plus the cosine of 2 theta. That's why I put those three together like that. So we're going to scoot on up here to the third column. And sine of 2 theta, this one, you actually use this a lot more than you use the cosine of 2 theta. This is the 2 sine theta cosine theta. ln of e, you should know that to be 1. Log of 1 is 0. ln of 1 is 0. You should know that. Those come up a lot. Sine of x equals 0 when x is equal to 0 or pi or any other multiple of pi, 2 pi, 3 pi, and so forth. Cosine of 0 is cosine of x is equal to 0 at the top and the bottom, so multiples of pi over 2, so pi over 2, 3 pi over 2, and so forth. Or you could say pi over 2 plus pi k, k being an integer. Tangent of x is equal to 1 at the 45-degree angle mark, so that would be, in terms of radians, pi over 4, 5 pi over 4, not 3 pi over 4, 5 pi over 4, and so forth, continuing to add pi all the way around the unit circle. The limit as x goes to infinity of the inverse tangent. So this one comes up, not for a while, but it does come up later on in AP Calc. Just remembering the actual shape of the graph of the inverse tangent is really helpful. Then you can remember the limits. And so as x goes to infinity, this graph actually approaches the line y equals pi over 2, and as x goes to negative infinity, the limit is negative pi over 2, as you can see in my drawing. Now the inverse tangent of 1 only has one value. Some students put two values in here, but the inverse tangent of 1 is pi over 4 because the tangent of pi over 4 is 1. But you remember, when we're dealing with inverse functions, we're dealing with a restricted domain of the tangent function. So the tangent function goes only from negative pi over 2 to pi over 2, and so the inverse tangent has to be in the first or the fourth quadrant, but also from the values negative pi over 2 to pi over 2. So you can see pi over 4 is right there, and even though the tangent of 5 pi over 4 is equal to 1, 5 pi over 4 is out of the range of the inverse tangent function. Something to look up if you didn't really get it the way I said it. Inverse tangent of 0, well, tangent of 0 is 0, and that's within the range of that function. Inverse sine of radical 3 over 2, well, that's up here at pi over 3, because the sine of pi over 3 is radical 3 over 2, and the the range of the inverse tangent is the same as the range of the inverse sine. Now on the other hand, the range for the inverse cosine is different. That you're not allowed to use the third or fourth quadrants when we're dealing with the inverse cosine. So anyway, the cosine of pi over 3 is 1/2, and so that's within the range, and so therefore pi over 3 is the inverse cosine of 1/2. Alright, do we have time? Oh, this is not, let's see, 270 seconds. I gotta figure that out in a little over 3 minutes. Okay. Let's see here, we've got f prime of x. So the definition of the derivative would be limit as h goes to 0 of the difference quotient, f of x plus h minus f of x all over h. And f prime at a particular value a, we can use another actually pretty convenient formula here for the, or definition for the derivative. As x approaches a, of f of x minus f of a all over x minus a. So that's when you want to find the derivative at a point. Okay, and so then we have 4 different places where f prime of x fails to exist. So f prime of x fails to exist at, let's see. All right, I was thinking of one thing, but anyway, we'll use it this way. Fails to exist at corners, at cusps, at discontinuities, and fails to exist corners, cusps, discontinuities, and vertical tangents. Vertical tangents. Okay. That's 6 minutes. Let's see how this goes.